All right, good morning, Algebra 2. This is Mr. Smith. They say that you're supposed to provide a picture of yourself so that it feels more like the classroom. But here it is. We are going to be doing composition of functions. Let us start by talking about, by the way, you should have your notebook out. You should be able to take some notes here as we walk through some of the material. The first thing I want to introduce to you is a function machine. All right, a function machine is just a graphical way, a more concrete way to understand what a function is. So if I take this general machine here and I give a specific rule, something like this. So let's see, I'm going to have to make an output pretty close. So the idea is that I call this f of x equal to 2x. So the general purpose here is that we're going to be doubling all the inputs. So if I put a number in the top, it goes in the machine and out comes a 4. So let's see, let's plug a number in. Let's say that I plug in 3. All right, so I can plug a number in. Let's say I want to plug in 3. Notice that output turns into 6. I could even plug in a -2, and that output becomes -4. So what we have here is a way to think about what a function is and what it's not. So if I use function notation and say f of -2 is equal to 4, I can clearly see now that no matter what, if I plug -2 into the machine, nothing else comes out besides 4, or -4. So this is supporting our definition of a function. It's every single x has a unique one. I will never have more than one output for a particular input. So if I do this, if I put two machines together, that's what we're going to do today. So let's make two function machines. Let's use our original one we had. Let's go f of x equals to 2x. And let's say that we had, I don't know, let's make up another example. Let's say that f of x is equal to the square root of x. But what we usually do is give it different letters. So let's call this g of x. So I could do this. I could plug a number into both machines. Let's say that 2 goes into this, and let's do a 4. So 4 goes in and 4 goes in. Out of f, I'll get 8. And out of g, I'll get the square root of 4, which is 2. So I could go f of x plus g of x. What they're asking for is simply this. They want f of 2 plus f of 2 plus g of 2 is another example. And so what I have here is, let's see, f of 2 we said was 8. And then g of 2 is equal to 2. So that equals 10. So what we have here is we're adding the outputs from each machine from the same input. Let's do that again. So let's change the numbers here. Let's plug in. We can plug in, I don't know, let's say 8 and 16. So what we have here then, we're changing the numerical values. So what we have then is we have f of 2, f of 8 plus g of 16. Well, when 8 goes into f, we're doubling it to get 16. And then when 16 goes into f, we're square rooting it to get 4. So then we have 16 plus 4, which is 20. So we can do other operations. We can change this plus sign into a minus sign, which makes this into a minus minus. So we could say f of 8 minus g of 16 is 16 minus 4, which is 12. All right. Let's do some other numbers. So let's plug into our machines. Let's plug in 10 and 25. So when 10 goes into f, we get 20. We're doubling it, and then we square root 25 to get 5. So if we want f of x minus g of x, a specific value could look like this. We would have f of 10 minus g of 25. Let's see, f of 10 would be 20, and then g of 25 would be 5, and the output would be 15. Now I could do addition, I could do subtraction, I can do multiplication. If I multiply these outputs together, all I'm doing is changing the final operation. This now becomes 100. So f of 10 times g of 25 is 100. And finally, I can do division. So I can divide these two functions together. In this case, I get 4. Let's make this more concrete for you with these definitions. Let's see, I'm just checking to make sure I'm still recording. Yes, I'm still recording. We're 5 minutes in, as you can see up here in the top right. So your basic operations, here's the notation that you should write down. We have addition, subtraction, multiplication, and division. So here are 4 different ways that you can combine functions together. And with the function machine notation, I hope it kind of makes more sense. It's been 6 minutes since you've seen me. You've heard my voice. So let's go back. Here I am. Remember, this is Mr. Smith. I'm here in front of you, but not really. It just happens to be yesterday, but you're watching it today. So here's some examples. You might have to go back to the screen. Pause, you can write this down, whatever you'd like. So here are some more concrete examples. So look at this, there's 4 different examples. They give us 2 functions, f and g. Let's label these 1, 2, 3, and 4. So example 1 wants you to evaluate f of g plus x for a general x value. Let's do that second. The one example you should be recognized, that you can recognize is this one and this one, because we're plugging numbers in. So f times g of 4 would be f of 4 times g of 4. We're plugging 4 into both functions. So that's going to be, if f of 4 goes into this function, the number is going to be this. It's going to be 2 times 4 plus 3. And then we're going to have to multiply that by g of 4, going into the quadratic. That's going to be 4 squared minus 3 times 4 plus 2. So now it's just arithmetic. Now I'm going to add 12. Now this is 8 plus 3, which is 11. And then let's see. That's going to be 4 squared. I'll write it out. It's going to be 16 minus 12 plus 2. And it looks like this is going to be 11 times 4 plus 2 is 6. So I get 66. Number 4 you should recognize. For f of 6 over g of 0. Well, that's just plugging 6 into f. So f of 6 is replacing, it's going to be 2 times 6 plus 3. And then we'll divide that by g of 0, which is 0 squared minus 3 times 0 plus 2. And it looks like I get 15 halves is my output. So if we look at examples 1 and 3, we can see we don't have numbers to plug in. So what they're looking for you to do is they want you to come up with an algebraic expression and simplify it. So f plus g of x is the same as f of x plus g of x. Well, I can see f of x is right there. F of x is 2x plus 3. And I'm adding to that g of x, which is x squared minus 3x plus 2. What I can do now is look for like terms. The like terms are x squared, 2x, and negative 3x, and then the 3 and the 2 can be put together. So then adding those like terms together, let's see if I do this right. X squared, it looks like I have a minus x and then a plus 5. So this would be the rule for the addition of the 2. I can also subtract them. Let's do that with number 3. So f of x minus g of x. F of x is the 2x plus 3. I'm going to be subtracting g, which is x squared minus 3x plus 2. And the only thing you got to watch out for is this minus sign does distribute. So I'll get 2x plus 3 minus x squared plus 3x minus 2. We can look to combine like terms. It looks like x squared. I have a 2x and a 3x, which is a 5x. And then I have a plus 1. Now, I'm willing to bet that I made a mistake somewhere. You'll probably show it to me on Thursday. But if everything did the math right, it should be okay. Let's look forward here. So, composition. So, let's go back. There are 4 ways to combine functions. We can use addition, subtraction, multiplication, division. A fifth way would be combination, composition. Let's use our function machine to introduce this concept. Let me make sure you're still there. Where's my timer? Here's my timer. And good, 10 minutes in. It's been 5 minutes and you see my face. Let's do another visit. Here I am. Say hello, but not really. All right, so I'm still with you. Are you still with me? We're going to now do composition. So with the function machine, let's take two functions. Let's say that we have a function here, and we have an output, and let's say that it's f of x. Let's take the input times 3. Then let's strategically place another function below here, and then let's say that this is g of x. Let's take the input minus 2. So look what happens here. I do not put a number into both machines. I put a single number here at the top. So let's say that 2 goes into f. If 2 goes into f, then I multiply that 2 to get 6. And the machine will drop that output as an input for g. So if 6 goes into g, I'll get 6 minus 2, which is 4. Well, so notice how that's different. With my addition, subtraction, and multiplication, I could put 2 different numbers into f. I could put the same numbers, but we never saw the output become the input. But with composition, I can now take the output from one machine and put it into the input for another machine. Let's look at some different numbers. So let's change this up. So if I plug, I don't know, let's plug 5 into here. If 5 goes into f, I'll take 3 times 5 to get 15. That 15 drops into g, and then that will give me 13. All right. So the weird thing about composition is that order does matter. So suppose I do this. Suppose I rearrange my machines, and I'm going to take that function I just erased, which was x minus 2, and that was g. Call this g of x. And then I'll drop the f machine down below here. That was tripling it, so this is f of x equals 3x. So if I now put 2 into the top, the 2 now goes into g and I get 0, and the 0 would drop into f and I'll get 3 times 0, which is 0. So order does matter, all right, as far as which machine you plug in first and which one is second. So notation, here's notation. Let's go back. Here it is, another way to combine functions. So what you're going to recognize is there's 2 different ways to write the composition of 2 functions. Putting one function into another is the English version, and we're not going to worry about domain just yet. But here is notation. Let's see if we can't make sense of this notation with our machine. We might have to press pause for a moment. All right, so if I have these 2 functions, f and g, let's draw this out. So what I have here is, let's say that this is g of x equals x plus 2. And let's say that I have another function, f, and this is going to be, f is going to be 3 times x. So let's see here. If I plug 2 into g, that'll be 2 plus 2, which is 4. Then that 4 drops in. I'll take that 4 times 3 to get 12. So using our function notation, our composition, this would be, it would be f composed with g of 2, which is the same thing as f of g of 2. And with this, we say that we read left to right, we compose right to left. So with this notation, we would have f of, well, g of 2 we already found was 4, and then f of 4 is 12. So this is notation for composition. Now let's reverse that. Let's say that we plug a number into f first. Let's take 2 and plug it into f and see what we get. So 2 goes into f, and so out comes a 6. But then that 6 goes into g, and out comes an 8. So for that purpose, let's write that out. It'll look different. It'll look like this. So it goes into F first, we said, so it's G composed with F, G composed of F of 2, which is G of F of 2. So once again, we read left to right and compose right to left. So here we have a case where F of 2, we said was 6, and then G of 6 is 8. So that's our composition. I think I have another example here. Oh, here we go. So look at the examples here. So they want F of G of X. That means we're going to take G of X, the rule for G of X, which is X squared minus 3X plus 2, and we're going to place that into F. So what we have here is this. F says to take 2 times something plus 3. Well, that something is X squared minus 3X plus 2. Let's simplify that a little bit. I can get 2X squared minus 6X plus 4 plus 3 plus 7, and compare that to G of X. Let's do G of X below, or G of F of X. G of F of X is the same as G of, let's see, so let's do a different color. So G is taking, F is taking 2X plus 3, so that's 2X plus 3, and I'm going to replace, I'm going to rewrite G, so G is saying, well, let's do this, let's take something squared minus 3 times something plus 2. Well, that something is 2X plus 3, so 2X plus 3 squared minus 3 times 2X plus 3. We're going to have to do a little algebra there to simplify that, but hopefully you get the concept. All right. All right, so let's do the second example. The second example says, let's see, we're going to actually find numerical values. So we want F of G of 2, and we're going to find G of 2. All right, that means we're going to go F. Well, G goes in, 2 goes into G, and I get 2 plus 2 because I'm taking X plus 2, which is F of 4. And then F of 4 is what I get when I plug 4 into F. Well, F says just take the input and put it 1 over 4. So there's the answer. Let's do the next one. G of F of negative 4. Well, let's see. Negative 4 goes into F. So F says let's take the input and put it underneath 1. So that's negative 1/4. And then negative 1/4 goes into G, where G says we're going to take X plus 2. So that's going to be negative 1/4 plus 2, which is 7/4. Okay. Are you still with me? Let's see. Let's go back. How long has this been? 18 minutes is all I ask here. We're done with these notes. You might have to revisit. You might have missed something. I fully expect at least 2 corrections of at least arithmetic errors or something I did wrong. But here it is. Let's take your quiz, followed by your worksheet.